So one of the things that will be a nightmare, I think, for companies when we have a AI regulation is when engineers have to implement privacy, fairness, and interpretability. So one of the difficulties that they will have is already to move from like the description of high principle of the ethical issue to really what it means to do in practice. But also when they have to do all these three things together, they will have some tensions that I want to discuss afterwards. So it's going to be already moving from what people sometimes call like privacy engineering. So how engineering really privacy in the system is difficult, but also how to do all these three things at the same time, there will be some issue to solve. So one of the tensions between privacy and fairness, for instance, is that usually when you do privacy, you want to collect as little information as possible. So one of the principles in privacy is called data minimization. Only collect the information that you need for a particular purpose or services. But then when you want to measure the discrimination or improve the fairness of a system, usually you need to have access about sensitive information like the gender, the race, or the religion. So you already see that there is some kind of tension between I want to collect as less information as possible to be private, but to be fair or to measure the fairness, I will need to collect sensitive information. So this is the first tension. Another tension is people have shown that when you do the privacy attacks that I mentioned, like membership inference, usually the success of attacks is higher against subgroups. And this is the case in general because the subgroup, and sometimes we call them minority group because there are very few individuals. So the model tend to learn more information about each member of this particular group than if you have like a majority group, where basically the information about a particular profile is going to be diluted in the mass. So minority groups usually are even more vulnerable to the privacy attacks. And also there is, in the other direction, people have shown that if you train the machine learning model to be fair, usually you you make some information, some privacy attack also more accurate. So by training the model to be fair, you will memorize more information about the sensitive attributes, and this sensitive attribute can be used to also do the attack more efficiently. So you already see that you can train model to be fair, but then you might increase the success of the privacy attack. And this is an example, just to give you a concrete example. This is a table from a paper from last year, which was called Disparate Vulnerability to Membership Inference Attacks. So I will just try to explain that if you look at the column on the right here, what is called the subgroup vulnerability is how much this particular subgroup is more vulnerable to membership inference attack compared to the majority group of the population, and the higher, the more the subgroup is vulnerable. So basically, it means that if you look at Asian Pacific Islander, the success rate of the privacy attack is going to be 5 times higher than if you lose at the majority group of the population. So this is just showing that basically some groups will be more impacted in terms of what can be deduced about the particular profile. And this also was with 32 neural network and 8 neural networks. So this also shows that if you increase the complexity of the machine learning model, the subgroup vulnerability augments. This is linked to what I was saying before. The larger the model, the more complex the model, the more information it will remember about particular profiles. One of the work that I did also was to show that basically, if you train a model to be fair, you can reconstruct the sensitive attributes more efficiently. So this relates to what I was mentioning about the success of privacy attacks being even higher if the model is trained to be fair. And this is a paper that we had this year, sorry, with a PhD student in Toulouse and other colleagues in Montreal and in Toulouse. So this is also one example of tension. So of course, there is some convergence between privacy and fairness. So for instance, in privacy legislation, you see that there is some provision on profiling. So in particular, that profiling should not be based on sensitive attribute and not discriminating. So you see that in this case, privacy and fairness are aligned. One thing that could be also, I think, easy to add is no company, at least in Europe, have to do a privacy impact assessment when they develop a technology that use personal data. So basically, they have to do a risk analysis about the data that it uses and the risk and the protection mechanism. And there is a lot of suggestion to say, okay, so now that company have to do this privacy impact assessment, maybe they could instead do what people call an algorithmic impact assessment, where you include privacy, but you also include fairness and interpretability. So this could be also included already in the risk analysis that they have to do. There is also some work that shows that basically individual fairness, where it's the fact that the system gives the same prediction to two profiles that are similar, is also a form of differential privacy. So basically, when you do differential privacy, you hope that the system is not too much impacted by a particular profile. So you can try to make sure that if you have two inputs that are quite similar, also the system will reach individual fairness by implementing some form of differential privacy. There is also people that have worked on way to achieve fairness, even if you don't have access to sensitive data. So even if I don't have access to the gender or the race of people, I can try to use some technique from robust optimization to train a system to be fair. And another connection is also one way to do fairness, as I was mentioning before, is to change the input data to avoid the fact that the bias will be propagated in the model that is learned. So if you try to decorrelate, so one of the issues with that I should have mentioned is there's still a risk of indirect discrimination between what people call proxy. So a proxy is an attribute in the profile which is highly correlated with a sensitive attribute. So to give an example, if in US you don't ask for the race of a person, but you ask for the zip code, there is a high chance that the zip code is highly correlated with the race, because there is some neighborhood in some city in US which are with some predominance from like Afro-American, white, Caucasian, or Hispanic, Latino. So even if I don't ask you the race, if I ask you for the zip code and the model uses information, then there is a risk of indirect discrimination, but there is a possibility also to try to modify this information to also reduce correlation. So this is a connection or convergence between privacy and fairness. So now if I go between, so imagine that you have this triangle of privacy, fairness, explainability. We have seen a tension between privacy and fairness, but now if you go between privacy and explainability, I mean, the most intuitive tension is that when you give explanation, you give additional information to the adversary. So you don't just give the prediction, you are going to provide some explanation. So one example of explanation that people use, for instance, is counterfactual. So the example would be that you go at the bank, you ask for loan, and the response is no. So rather than just having a negative answer, maybe you would like an example of a profile which is not too much different from you, which would have received a positive decision. And this is called a counterfactual profile. So for instance, this profile says that if you work full-time instead of part-time, and if you go get a master, then basically you would have a positive decision for the loan. So of course, if you do that, you see that you give a lot of information to the adversary. You say that the original profile will have negative decision, but you also give an additional profile with a positive decision. And so one of the issues is that when people do counterfactual explanation, they are likely to also give a lot of more information to the adversary to do the privacy attack that I mentioned. So this is really I would say, the first tension. And we did, for instance, a work a few years ago showing that when you want to steal a model to do a model extraction attack, is very easy with counterfactual explanation. So there is also some convergence between privacy and explainability. So the first one is that we see in the GDPR that the right of explanation is directly also included in the privacy legislation. But the challenge is also, what does it mean to be a good explanation? So here also, similarly to fairness, I think now there is a kind of consensus that explanations are context dependent. So if you are in a medical domain or if you are in a bank, I don't think that you would like the same type of explanation. Also, if you are the end user, which is affected by the prediction, or if you are the debugger of the model, or if you are the auditor of the model, maybe the explanation that you want is not the same. So there is also dependent on the public. Another convergence is that if you train a model to be differentially private, and the explanation is just post-processing that doesn't look at the training data, there is also work which shows that the explanation respect the differential privacy. So there is a way to have explanation and differential privacy together. Or there is also people that have proposed differentially private explanation method directly, even if they look at the training data. So once again, my objective today is not to go in detail, but I just want to point out, if you look at the name of most of this research, these are very recent papers. So a lot of work on like the intersection of privacy and explainability, I would say have 1 or 2 years old, not so much. So this is also a very active area of research, and the number of papers are not exploded yet. So if you do a PhD and you are looking for a subject, I think it's still manageable to do your literature review in 6 months, if you look at this kind of topic. So just to mention that in case there is some of you which are trying to decide on subject and trying to understand what is the scope of the literature review. One of the convergence between explainability and fairness, so this is another part of the triangle, is that basically when you want a model, you use an interpretable model, you can also use fairness as a way to be sure that the model that you learn is accurate and fair by design. So we did a work, for instance, on rule list, where so it's similar to decision tree, where basically you try to apply a series of rules. And so one rule could be, is the age of the person and the salary above some value? And if yes, then you predict this particular decision. If not, you try to apply the next rule. And we show that it's possible to learn model which is explainable and fair at the same time. So fairness and explainability, there is convergence, but there is also some tensions. And the tension is a bit the same that we had between privacy attack being more efficient for subgroups. Basically, people have shown, and this is also a very recent paper from last year, that when you give explanation to people, so when you do, so okay, let me explain the diagram. So basically, imagine that you have a black box model like a deep neural network. So what people call the decision boundary can be very complex. So the machine learning model is separating the blue and the yellow prediction. So maybe the orange is the loan is refused and the blue, the loan is accepted. And also in the population, you have 2 subgroups. You have the subgroup of square people and the subgroup of triangle people. So if you look at the original decision boundary, I mean, it clearly also separates the 2 categories very distinctly. But if you try to approximate this decision boundary with a interpretable model, so the interpretable model will have a decision boundary which is less complex, and you look at the quality of explanation between the triangle and square, you will see that for the triangle people, which are actually the majority of the population, there is 9 of them, the decision boundary of the interpretable model is quite faithful to separate the orange triangle to the blue triangle. But if you look at the minority group, basically it's very bad in terms of trying to explain the decision from the original black box. So basically people have realized that you can have also a disparity in terms of quality of explanation. So imagine that it means in practice, imagine you go to a bank, if you are in a minority group, the explanation that you get maybe is rubbish, so it doesn't really help you to change your credit score. But if you are in the majority group, the explanation you get is very relevant. So this is also a kind of disparity, but more in the quality of the explanation that you get. So this is also a tension between explainability and fairness. Now also, one thing I want to discuss is between privacy and security. So in machine learning, I've not talked about this, but there is a lot of work on what people call adversarial machine learning. So I don't know if you have already all heard this term, but basically, this is a line of work where people have shown, for instance, that if you have a picture of a particular animal like a panda, and you just add a little bit of noise for a human, basically it's still a panda, but the system will make a prediction like on a different class. And this, for instance, I mean, a lot of company working on autonomous vehicle are very afraid of this kind of thing where you can just modify your, I don't know, your t-shirt, and it will make the system completely think a bad prediction. So there's a lot of work on security in machine learning, even more than privacy in machine learning. And one of the tension between privacy and security is that when you try to make the system robust against adversarial example, which are this particular picture where you add noise, people have shown that you increase the security, but you also increase the vulnerability to privacy attacks. And this is because basically the information that can be used to distinguish between member and non-member, for instance, is much more clear after the security mechanism has been put in place than before. So this is also an tension between privacy and security. So you might also have to set up a trade-off on how much you want the model to be robust against adversarial example and how much you want it to be robust against privacy attacks. And even more, there could be also tension between privacy and privacy. So let me explain it to you. So first, have you all heard about the right to be forgotten? Maybe I can pause. Okay, I see people know. So basically, the right to be forgotten in machine learning, people have called it machine unlearning. So it's a process of removing your impact on the model which is learned. And so one way to do that could be, for instance, to split the training data in shard and to learn several models on each shard. And so when we want to erase your impact on the aggregate model at the end, we only need to retrain this particular model. We don't need to retrain everything. And so this will be really, if a company is willing to remove you from the model, if you ask for your data to be deleted even from the impact on the model. So it's go very far. It's not only the data that it's stored, but also the impact on data that has been inferred like the model. So when you want to do machine learning, it's possible to do it, but basically people have shown that when you do machine learning, it's also helped to do the membership informed attack. So one thing you can do is you have a particular profile in mind and you have a model before the update and after the updates. So after the profile has been removed. And basically you can try to look at the prediction before and after to decide if this particular profile was in the data. So basically, if your profile was the one that has been erased, the prediction of the model are going to be very different after you have been erased and before you have been erased. In particular, the confidence of the model are going to be different. So this is even what I call a tension between privacy and privacy. So if you do machine learning, I don't know if there's a company yet that does that. So I think I forget the name of the company, but in Quebec, we had a company doing machine learning model for medical data that were proposing to do machine learning. But I don't know a lot of other examples about that. But so if you want to do machine learning, it's like you try to give additional privacy feature to user, but basically you can also increase the chance of maybe doing some privacy attacks. So you might have also some tension between privacy and privacy in this context. And the last thing I would like to mention as a tension is what I call ethical washing. So basically, as long as we don't have a regulation that really set what is a good way to, what is a good fairness definition or the good explanation. I mean, we have seen at the beginning that basically the company will call with the kind of soft regulation where they develop their own ethical framework. And one of the risks is that basically a company will try to promote to the public the perception that the model that they have trained is ethical with respect to fairness or explainability, while it's not the case. And we call that ethical washing in machine learning. So basically, ethical washing is already something that people have studied a lot in business. I mean, maybe you have heard about, I don't know if sorry, I don't have cartoon, but greenwashing is when a company try to say that the products that they do is environmental friendly. So you have a lot of petrol company, for instance, which will say that what they do is green. And sometimes what they just do is just say that what they do respect the law and nothing more. Or sometimes they even do false advertisement on things that are not true on the ground. So to give you what could be one example of privacy machine in machine learning, so here I'm sorry, it's in French, but basically this was an advertisement about 6 years ago from Apple, which tried to say, so I will try to translate, your functionality are improving, your data remains protected because we know try to use your data to offer you a better experience, but trying to protect your privacy. We use a new process called differential privacy. So by the way, for researcher in differential privacy, it's so it was 2017 and differential privacy was invented in 2006. So it's really funny to see when we call it a new process when it's like 11 years after, but I mean, it's still good to see that this notion is now used in some products. But basically, so Apple was saying we now use differential privacy, so it doesn't use differential privacy in all the services. This was to protect the prediction of emojis. So maybe this is not the most privacy sensitive feature, but still Apple was saying, hey, we do differential privacy. But one thing I should have said is that in differential privacy, you have a parameter called epsilon, which defines the level of protection provided. And basically, the smaller this value, the more noise you have to add and the better the protection. But Apple was saying, okay, we do differential privacy, but we won't tell you what is the value of this parameter. And as a researcher, we know that if you go above a particular value, the protection you provide is meaningless. So there is no noise. And so a few months later, basically, a few researchers have been able to reverse engineer what Apple was doing. And they show that the value of epsilon is 14. So I know it doesn't mean much to you, but in practice, it means that there is almost no noise. So I call it an example of privacy washing because the company was saying, okay, we respect your privacy, we do differential privacy, but we are not telling you the full story. We don't tell you the value of the privacy parameter. And then when you look at the value of the privacy parameter, there is almost no noise. So it's almost like no protection. So this is an example where the companies say, okay, I'm going to protect your privacy, but they don't go really to use a value that makes a lot of sense in terms of protection. Another example I could give of ethic washing, but more in terms of fairness. So if I go back to the Compass tools that I was mentioning for predictive justice, basically there was a lot of news about this tool being racist because there is a collective called ProPublica, which basically shows that if you are Afro-American, you have twice as likely to be put as high risk. And this was a public report called Machine Bias, if you're interested. And basically, if you remember the fact that there is this tutorial about 20 notion of fairness, basically the company which was doing this software, which is called Northpoint, and now I think it's changed to Equivant, they were saying, okay, but the study is interesting, but actually you didn't look at the right fairness notion. If you measure our system by using this different notion of fairness, you will see that this system was fair. So basically, the company is trying to say our system does not discriminate because you didn't use a good measure. So one way to do fair washing for a company. So imagine you have created a machine learning model. You didn't care about fairness, but you saw that there is a high risk that there is an AI regulation coming in the next month. What you could do is use all of this 21 notion of fairness for which there is tens or hundreds of citations in scientific papers. And if there is one where you find out that the system is fair, you could say, oh, my system is fair according to this notion. So it's like cherry picking your fairness notion. So it's a way to do ethical washing. You didn't care about fairness you just tried the 21 notion and you pick the ones that make you appear to care about fairness in this particular context. Another way to do fairness, and this is when you have a black box model and you try to explain it with the interpretable model is what we call rationalization. So basically, the idea is that you might have a scoring system which is discriminating against particular group in the population, but you are replacing this black box model with an explanation API, which is, for instance, an interpretable model that try to explain a neural network. And what we have shown with, and one thing that will happen is when you replace a black box model with an interpretable model, there is a lot of different models that can have the same fidelity in terms of prediction to the black box. And so people call it predictive multiplicity. So basically, there is not only one decision tree, but there is tens or hundreds of them which have the same quality of prediction to the black box. And one way to do fair washing is to look on all these models, the one where the fairness appear to be good, even if it was not good on the original black box. So here, fair washing is done by cherry picking the particular interpretable model, which will look that your system is fair while the original black box was not fair. And so in different work that we have shown is basically we have been able to show that fair washing is possible independently on the data or the particular model. So it's something you can do with deep neural network, but also with boosting algorithm or random forest, which are other type of model. And it's possible to try to detect it, but it's difficult. So this is also a work we did from last year at NeurIPS, which is a machine learning conference. And basically, I think ethical washing will be difficult to detect in general, because ethical washing happen in general when there is a gray area in terms of legislation. So as long as there is no, so when I say legislation, it could be also a standard from a particular, I don't know, the order of doctor in Quebec, which says that in this particular context, you should use this type of explanation or this type of fairness. So as long as you don't have norms and there is a gray area, I think there is a lot of space for company to cherry pick the fairness notion that they want or the type of explanation. And so it's in terms of ethical washing, I think proving the intentionality is going to be difficult for the judge. So when the company tell you my system is fair according to this particular notion, it's very difficult to know that really the system was trained with this notion in mind, or just the company is trying to do some fair washing. I mean, unless you have some data from inside the companies that prove that people didn't care or care about the fairness, it's going to be very difficult, I think, to prove the intentionality just based on the prediction on the system. And so I think a possible solution is really to have a standard or a regulation which is trying to say on this particular context, what is the notion that you want to use, the fairness notion you want to implement on the type of explanation. And if you can really specialize or have a standard which is more specific, there is a way also to use cryptography to prove that the system was trained according to this particular fairness notion and this particular standard. So without revealing the original data. So just to say that there is also work being done on how to prove to external auditors that the model was trained according to a particular algorithm. But of course, as long as the legislation or there is no standard specifying what is the notion to use in terms of fairness, explainability, or privacy, I think the company will still use the one that fits their need. And that's why also hopeful that regulation in AI will try. So by the way, I should be more clear. So what I hope is that we will have a regulation in AI, which will try to give like generic principle, but also after that by sector, we will have a really committee of experts saying, okay, in the bank domain, this is the notion of fairness that we want to use, and this is the notion of explainability that makes sense. Having stakeholder also representatives, the civil society, but also like all the stakeholders, like the banks themselves, but all maybe the so like the financial market regulator and other type of thing. So yeah, so if we could have more specific standard by sector, this will also help to try to audit and verify that the company don't do ethical washing. And this is the end of my presentation. Sorry, I know I'm a bit over time, but I can take any questions that you have.